All right, so I've got the light on because I can actually see now. So expectations, remember this is a huge unit, so make sure you're taking your time and asking questions and figuring stuff out, and we're good to go. There are more resources on my website. Okay, so unit objectives, we are now on multiplying polynomials. So we're going to just do polynomial by polynomial. Again, we're going to work on the area model. So just an FYI, I'm going to do both methods, but then it's up to you if you prefer one or the other on whatever practice or worksheets that you are working on in your classroom. All right. So, again, we are on the back side of our table of contents. We just finished page 42. We are now on page 43. So let's go look it up. Let's go look it up. Multiply polynomials. So again, we are going to have steps circle in the middle. So let's draw a circle in the middle of our paper. So the steps that we are going to follow, we're going to multiply each term in the first polynomial. Again, we're going to say polynomial a lot, so if you want to abbreviate with poly, go for it. Polynomial by each term in second polynomial, and then we're going to combine like terms. All right, so this first step is actually the same as distribution. It's just a little different because we're used to distribution with only one term. I'm going to put these up with only one term. So it's going to look a little different, but it's actually the same concept. All right, so we are going to have 4 examples again. So if you want to draw your arrows ahead of time, area model will again be on this left-hand side. All right, so remember the area of a rectangle is length times width. That's where this idea is coming from. So for our first example, we're going to multiply 2x minus 3 by x squared minus 2x plus 1. Now I'm going to switch to a pen because it is a little thinner since our steps took a little bit more space. But I do want to mention that, yes, I have this big old rectangle that I'm looking at. This is the length, this is the width, or vice versa, doesn't matter. But there are 2 terms in this length, which means I need to split it into 2. So 2x goes on one and negative 3 goes on the other. They could be switched, it doesn't matter. And that's the beauty of multiplication. You can switch them up. As long as that negative sticks with the 3 and the positive 2 sticks with the x, you're good. And then for this second one is a trinomial, so I'm going to have an x squared minus 2x plus 1. If you want to put the plus so you remember it's a positive, you're welcome to do that, but you don't have to. And now we just find the area of each little square. So it's breaking down our multiplication in a visual way, all right? And if you liked array multiplication, you probably will like area model. So 2x times x cubed, or x squared, is 2x cubed. All right, I'm going to pause the video. I want you to fill in this area model, okay? So I'm going to do it pretty silently or just talk to myself and then come back and check yourself. Okay. And it is helpful sometimes to write a positive next to your term because you are going to be putting that positive back when you combine like terms. And before I'm not going to write it all out and then combine like terms. I'm just going to combine them while they're in the area model and then spit out the actual final answer. So my highest degree is 2x cubed, so I know that's my answer. And then I have my x squareds, so I'm going to get negative 5x squared. And I have my linear terms, which is positive 8x, and then my constant of a negative 3. Boom. There's my answer. Okay? And so it is really nice. Sometimes this diagonal pattern does not always happen, but it's really nice because it does happen pretty often. Okay, so then moving from the area model, what if you don't like that? What if that takes up too much room and you are one of those that likes to write teeny tiny? That's fine. I never heard of the area model until I was teaching. So it's all good. But in math, there's way more than one way to even do a problem, which is the fun part. Okay, so write down that, and then instead of doing the area model, I'm going to do my rainbows. Again, I am going to do this in a pen, just so it is more fine and it can fit better on the paper. So I'm going to multiply each term in the first polynomial, which we did that over here. In the first polynomial, I multiplied 2x by every single term in the second polynomial. I did 2x multiplied by x squared. I did 2x multiplied by negative 2x. I did 2x multiplied by positive 1. And I did the exact same thing for negative 3. Multiply, multiply, multiply. I'm going to show that same work, but with arrows or rainbows instead. So I'm going to have 7x squared times x squared. So that's going to get me 7x to the 4th. I'm going to do 7x squared times negative 5x, which that's going to be negative 35x cubed. 7x squared times negative 1, negative 7x squared. Now, I have a second term. So I had 3 arrows or rainbows going from this first term. I'm going to have 3 more coming from here because there are 3 terms over here. So I'm going to end up with 6 rainbows in total. If I look over here, I had 2 terms and 3 terms. I had 6 boxes in total. So if you're going to do the area model, the number of boxes you're doing should be the same as whoever's next to you and they're doing the rainbow. They should have the same number of rainbows as you have boxes, all right? It's the number of terms multiplied by the number of terms. If that isn't working out, then you're doing something interesting, and make sure you go look back and see what you're doing. Okay, next one, negative 2 times x squared. Now I could keep writing this next to it, but sometimes it's nice to jump a line, because these line up, and that way I already have my terms lined up. Sometimes it's helpful. Other times, like in this case, it's not the most helpful because my next rainbow gets me a positive 10x. There were no like terms, and then I get a negative 2. Again, there were no like terms. So in this case, it wasn't the most helpful. It did tell me, though, that I only have to combine 1 pair. So that was nice. And that was my answer. Woohoo! So they took about the same amount of work. I guess this is more boxy. This one's more linear. So if you like going every line and seeing what happens different, I would definitely do the rainbow model. If you're okay with just this whole chunk is this problem, this whole chunk is this problem, then I would definitely do the area model. All right, so we're going to do 2 more. And then I'll have a challenge at the end. If you want to spend the time with it, you don't have to. It's just to look for more patterns. Again, I'm going to write examples 3 and 4 at the same time just to make sure that you have room. They're not long. If anything, well, I guess example 4 is kind of long. Should not have touched my face. Glasses are helpful. They protect your eyes. Okay, so that's why I play with my eye even more. Okay, so for this example, or in example 3, I'm going to use area model again on example 3, but just an FYI, if you prefer the area model, then try that for example 4 because it is such a larger question, or vice versa. If you like the rainbow model, then try that on examples 3 and 4. Practice what you want to learn and perform better and work and master with. So the more you practice it, the better you're going to get. So for area model, this would be a 2 by 2. And you're going to see a lot more of the area model being helpful later with a 2 by 2. All right, so getting familiar with at least the 2 by 2 will be really nice. So this will be 7x and 2, 5x and 1. You could switch the sides. The 7x and the 2 could be on the top, and the 5x and the 1 could be on the left-hand side. Does not matter. You could also label them on the right-hand side. It's just typically people put on the left to right because we read from left to right. So keep that in mind. Do it on your own. See what y'all get. Is that what you got? I hope so. All right, let's do example 4. And I'm going to do it with rainbows because I'm doing lots of different weird accents that just blend into each other. Okay, so again, I have 3 terms by 3 terms. So I'm going to need 9 arrows. So if it helps, you can always, I guess that's one's black and we'll do a brown too. Why not? My green marker's all the way over there. So I'm going to do 3 different colors, and that way I can make sure that they're keeping track. It's really nice when you only have 2, because like on this one, I could have done 1, 2, 1, 2. Then you have a top and a bottom, and you can tell the differences. But when you have 3, you don't really have more than a top and a bottom. So I'm going to do 1. So that'll be 10x to the 4th, 2, plus 4x cubed. 3 plus 2x squared. All right, I'm going to do black next. Make sure it's working. There we go. 3x times 5x squared, which would be positive 15x cubed. 3x times 2x is 6x squared. 3x times 1 is just 3x. And now for brown, negative 1 times 5x squared is negative 5x squared. Negative 1 times 2x is 2x. Negative 1 times 1 is a negative 1. All right, so the colors are kind of nice. It's fun if you have highlighters or something like that. And then I'm going to add them all together. So bringing down, because I already put them in standard form, it really was nice, because if your polynomials are already in standard form, when you multiply through, you're already going to end up with standard form. So that's really nice. Then x to the fourth plus 19x cubed. 2 plus 6 is 8. 8 minus 5 will be 3x squared plus 5x minus 1. I'm going to make this 10 look more like a 10. And then box my answer. I'm done! Woo! Okay. At the end, I do want to give you a challenge to find the pattern. When you are multiplying 3x plus 2 and 3x minus 2, another example of this pattern would be x plus 6 and x minus 6. I want you to multiply these, see what you get at the end. Why does that look different? What's special? What's something that didn't happen in these 4 examples? And then what's something that happens in each of these examples and what's causing it? So that'll be something helpful. It's helpful, but if you don't want to look at the pattern, then that's fine. This method will still work for you. This will just help you save time if you recognize the pattern for this specific situation. And a lot of this unit is just making sure you have shortcuts and more tools for when you see a special case. And that's going to blow your mind. If you go farther in math, it's finding the patterns to make your life simpler. But not every single thing follows that one pattern. Different patterns exist, so they all have different shortcuts. Sometimes there's no pattern, so then you have to do the long way. But sometimes there's a way to take that long way and get it into a pattern to make a shortcut. So that was complicated, overly verbose. So, woo! Yay! Think about what does it mean to solve a quadratic, because we're going to move into that at some point because we're graphing quadratics next. So we are going to solve them really soon. Keep that question on your radar. All right, and we're good. So thank you for watching and have a great day. Bye.